Good morning. In today's session, we are supposed to study about the delta modulation. In previous session, we have seen about the pulse code modulation. In pulse code modulation, n number of binary digits we can transmit per sample. Hence, the signaling rate and the channel bandwidth of PCM are very large. Also, when we are using the pulse code modulation, at that time we are supposed to do encoding, decoding and quantizing. So these circuitry of the PCM are complex. We have seen about the block diagram of the pulse code modulations, which uses analog signal which will do encoding by using the sampling, quantizing, encoding, and which will give us the data that will be the digital. It means what? We can convert analog signal into the digital by doing the modulation here. So it is the technique which we used for reworking of analog signal into a digital. So PCM, pulse code modulation, it is sensible signal to the signal to noise ratio. And if you see, PCM technique is split into three elements. These are nothing but we are dividing into three: transmitter, we are dividing into the path, that is nothing but we can say as a channel or the transmission path, and the receiver. So here we have seen when we are doing the pulse code modulation, at that time we are supposed to convert analog signal into a digital signal. It means what? Here we are sampling and quantized for the pulse code modulations. We are doing the sampling at the regular interval for each samples. So here we have seen when we are doing the pulse code modulation, at that time modulation is nothing but it is the process of varying one or more parameter of the carrier signal in accordance with the instantaneous value of the message signal. It means what? When we are doing the digital modulation, at that time we can transfer the data, we can transmit the data by converting analog information into a binary. These are nothing but 0 and 1s. It means what? The output of PCM will resemble a binary sequence, and we will get the output that will be instantaneous value we will get at the output. It means what? We can say we can convert analog value into a digital by using the pulse code modulation. So in today's session we are supposed to study about the delta modulation. It is the one other type of the modulation. So here firstly we will see about the how we are transferring the data. So in pulse code modulation we are transferring number of bits at a time, but if you see in a delta modulation we can transmit only 1 bit per sample. So here we can say it is the system in which corresponding to each sample we are supposed to encode single bit as opposed to the n bit in the PCM. It means what? In pulse code modulation we were sampling n bit at a time, but here we are supposed to sample single bit. So delta modulator transmits binary output pulse whose polarity depends on difference between modulating signal and the feedback signal. So here if you see about the hardware for the delta modulations, it is simple hardware and it is less costly as compared to the pulse code modulation, because here bit is a 1 if current sample is more positive than the previous sample, and it will have 0 if it is more negative, because here we are transmitting only 1 bit per sample. So here so little information we are transmitting, delta modulation will require higher sampling rate than the pulse code modulations for equal quality of reproduction. So if you see, delta modulation is having lots of features over the pulse code modulations because it is encoding only 1 bit per sample. So we will see thoroughly about delta modulation. Delta modulation sends only the difference between the pulses. If the pulse at time Tn plus 1 is higher in amplitude, at that time we are supposed to sample the bit 1. It is used to indicate that a positive value. And if the pulse is lower in value, we can say that will be resulting in the negative value. Here we are using only binary bits. So for negative value, we can use 0 bit. So this scheme will work well for small changes in signal value between the samples. And if the changes in the sample are in amplitude are large, at that time this will give us large error. It means what? If we are having the small changes in the signal value, at that time only we can use delta modulation technique, because if there are larger changes in the amplitude, it will give us lots of error. So here we can see how we are doing the delta modulations. If we are having the input signal that will be analog, like a sine wave, you can see here, if we are having the sinusoidal wave, at that time by doing the delta modulation, we can convert that value to the positive or negative. It means what? To the 1 or 0, as shown in diagram. You can see here. So here what we are saying about the circuit diagram, the block diagram of the delta modulations. If we are supposed to use delta modulation circuit, at that time we will give the input that will be analog, and here by using the delta modulation modulator, we can convert that analog signal into a digital. So here it will consist of analog signal, digital signal, and the delta modulation modulator. So here firstly we will see about the delta modulation.